Assalamualaikum and good afternoon. Okay, today we continue a new chapter, Grid-connected Photovoltaic Power System. Table of contents. So we start with introduction. Number 2, components of a grid-connected PV system. Number 3, grid-connected inverter. Number 4, design procedures. Number 5, system prediction. Number 6, installation. Number 7 is a TNC, test and commissioning. So in here, I already wrote down all the information that I want to say. Start with introduction. Introduction, a grid-connected photovoltaic power system, GCPV, is electricity generating solar PV system that is connected to the utility grid. So in Malaysia, for the GCPV system, only available in Peninsular Malaysia and Sabah. The feeding of electricity into the grid requires the transformation of DC into AC by a special inverter called grid inverter or intertie inverter. So this is a special inverter which is it requires the grid connection. Point number 3, there are two types of connection of GCPV system to the grid, which is direct connection and indirect connection. For this direct connection, this type of connection is used when all the energy produced by GCPV is transferred to the grid. In some countries, the owner could sell this energy with a special tariff called feed-in tariff, FIT. So most of the PV solar farm use this type of connection. For residential installation, example less than or equals to 12 kilowatt peak, the point of connection is at the incoming cutout fuse. But for the larger system, example 1 megawatt peak and above, the point of connection is at 11 kV, and for larger system, the point of connection is at 33 kV. So where is this connection? 33 kV usually at pencawang masuk utama, PMU. Indirect connection, the point of connection is at the electrical distribution board, okay, your DB board. This type of connection is used if the energy generated by the GCPV system is for the owner own use. Only surplus energy will be transferred to the grid. However, in some countries, the utility does not allow any amount of power transfer to the grid. Thus, a special controller must be installed to prevent excess power flow to the grid. So, if you refer to this statement, indirect connection, which is for the first statement is for the owner own use, this is usually under NEM scheme. Okay, net energy metering scheme. So only surplus energy will be transferred to the grid. However, for the second statement, this one, however, in some countries, the utility does not allow any amount of power transfer to the grid. So in Malaysia, we call this scheme as a SELCO. Okay, self-consumption. SELCO. SELCO. So to prevent this surplus energy to be transferred to the grid, so they need a special controller. Okay. So it was estimated by the end of 2016, total installed capacity of GCPV system in Malaysia is 99.7 megawatt peak. 2016 is already 235 megawatt peak. 2018, the GCPV annual generation under FIT, feed-in tariff, is about 360,513 megawatt hour. So in Malaysia, SEDA, which is Sustainable Energy Development Authority, is an organisation that manages feed-in tariff for all types of renewable energy. So it includes biomass, biogas, hydro system, and the PV system. Okay. In general, GCPV could be classified into system, a distributed system, which is many scattered small system, for example, from the residential area, and centralized system, which is a large-scale solar farm, LSS. So GCPV system centralized at one area. So grid-connected system vary in size for residential, which is less than or equal to 12 kilowatt peak, to solar power station up to megawatt. So please visit the following link to see the latest development of renewable energy in Malaysia, managed by SEDA. Okay, let's go to this website, www.seda.gov.my. So you click Fit in Tariff. Okay, so this is information overview of the FIT system. We can check the FIT rate. So FIT rate for solar PV, which is a community, 21 years from FIT commencement date. So this is starting January 2020. So basic FIT rate, so up to or including 4 kilowatt, about 54 cents ringgit Malaysia per kilowatt hour. If above 40 kilowatt until 24 kilowatt, about 0.52 cents. Above 24 and including 72 kilowatt, about 0.32 ringgit Malaysia per kilowatt hour. You have this bonus FIT rate if you have the following criteria, one or more. So number one, used as installation in buildings or building structure. For example, you install the PV module on the rooftop, so you get extra plus 0.10 ringgit Malaysia per kilowatt hour. Okay, about 10 cents. Number two is used as a building material. For example, you replace your roof tile, your rooftop with the PV module, so you will get extra plus 0.052. Okay. Number three, used as locally manufactured or assembled solar PV module. So you use local PV module, you get another extra plus 0.05 cents. And use of locally manufactured or assembled solar inverter or grid inverter, you get another extra plus 0.05 cents. Okay. This is the FIT rate. So this is cumulative installed capacity megawatt of the commercial RE installation. Okay. And the RE generation. Okay. Okay, so let's go back to the notes. So NEM still available this year until 2020. So this NEM, Net Energy Metering, regulated by ST, Suruhanjaya Tenaga, or Energy Commission, and implementing agency by SEDA, Malaysia. So this MEM only applicable for the solar system only. So to know about this NEM, you can visit the website again, website SEDA, or you can go to YouTube. There is an infographic about what is NEM. So NEM infographic in 1 minute. Okay. In SEDA, you can go to here. So in the SEDA website, this is an overview of the NEM, the new concept, the benefits, and then the guideline, and then the RPVI, Registered PV Investor for NEM program. So how to apply NEM calculator. So let's try NEM calculator. Okay, let's say your tariff is domestic. Okay, domestic, which is residential tariff. So let's say your house is a terrace house. Average electricity bill monthly, let's say my house is about 150 ringgit. So click calculate. So the proposed installed capacity is about 1.41 kilowatt peak. So from 150 ringgit that I need to pay every month, after I installed this capacity about 1.41 kilowatt peak, so my monthly bill after NEM it will be 77 ringgit. So I will save ringgit Malaysia 73 ringgit. So this is ROI, return of investment. So simple playback period is about 9.7 years. So this is the estimated minimum or upfront cost, which is about 8,460 ringgit. So if you refer to this calculation, you will know that this GCPV system only cover half of your energy demand, okay? About half, okay? But that one depends on the calculation of the tariff, okay? Because in the electricity bill, you have block 1, block 2, block 3, you need to calculate the tariff based on the block, okay? So this is the category of the block, the first 200 kilowatt hour per month, how much, okay? That one depends on this calculation. So for your awareness on the environment, okay, you will reduce your carbon dioxide avoidance about 29 tons. The distance travel avoidance by car about 0.1 million kilometer for this capacity. And number of trees seedling grown for 10 years to absorb the CO2 about 565 trees. Okay, this is how interesting this NEM calculator. So go back to the notes. So this NEM, we have 3 categories, which is number 1 is domestic or residential. So the capacity is less or equals to 12 kilowatt peak. For a single phase or 3 phase, can go up to 72 kilowatt peak. Okay, and then for the commercials and also industrial. So for commercial and industrial, maximum PV capacity show less than 75% of the maximum demand, or 60% of use rating, or 60% of your current transformer, okay, CT for megawatt system. So NEM assessment study, okay, NEMAS, is required for system which is above 72 kilowatt peak prior to NEM application to SEDA. If the system less than 72 kilowatt peak, so no need to do the NEMAS assessment study. For system which is greater than 1 megawatt peak, so it requires PSS, which is power system study. And for system larger than 24 kilowatt for single phase and greater than 72 kilowatt for 3 phase, require license from Suruhanjaya Tenaga or Energy Commission. So NEM type of installation on the rooftop of the building. It can be on the garage, car park or similar building, or ground mounted. That one you require a approval from Energy Commission. So for 5 megawatt is open for application starting from 1st January 2019. A mechanism where an eligible consumer install a solar PV system primarily for his own use and the excess energy to be exported to the grid, for which credit to be received that may be used to offset part of the electricity bill. So this one, it will offset your electricity bill. So you don't get amount in cash, but it will offset your electricity bill. So from 1st January 2019, the minister has announced 1-to-1 offset. Okay, so NEM, net energy metering, equals to energy import. So you feed your energy into the grid, minus energy export, which is you receive the energy from the grid, multiply with the gazette tariff for the NEM. So the quota for NEM is 100 megawatt per year. Total quota is 500 megawatt from 2016 to 2020. Let's see how much quota left for this year for the NEM. Okay. So this is the quota allocation. So Peninsular Malaysia 2019 to 2020. So for domestic megawatt AC, so the quota is 50 megawatt. So now the balance is about 39.59 megawatt AC. Okay, still a lot, Commercials, so the quota is 550 megawatt. So left, the balance now is 273 megawatt. So the total quota, we have 500 megawatt. So the balance is about 313.062 megawatt AC. So this is the quota allocation from 2016 to 2020. Okay. So we can see in 2020, allocation is higher compared to the previous year. So we go back to the notes. So the GCPV system is connected to the grid via DB. So a bidirectional meter is required to record, import and export energy. So this is the bidirectional meter. Energy meter, we have import and export. So the value. So this one connected to the distribution board. Okay. And the load and the GCPV system. So this is the concept of NEM without energy storage. So here is the utility grid. Integrated with energy storage is possible. A special inverter called hybrid inverter shall be used. So this is an example of the GCPV system with energy storage. So we use hybrid inverter. So the storage is a battery. And this is the PV array and the load. Okay, other than NEM, so we have another one we call self-co, self-consumption. So this self-co start in year 2016 and available until now, 2020, regulated by ST and implementing agency IA by SEDA Malaysia. So electricity generated is entirely for self-consumption, and applicants shall ensure no excess of power will be injected to the grid. Thus, a reverse power relay or a special power management controller shall be installed to prevent surplus power flow to the grid. So this is the block diagram, the concept of the self-co, which power management controller. So energy meter, we have sensor here. So this sensor will sense energy of the PV system. So this sensor will not allow the energy, the surplus energy, go to the grid by using this controller. Okay. So the sensor go to the controller, and then the controller will communicate with the inverter. So this inverter, the DC connected to the solar panel, and then feed to the decision board, and from this system go to the load, okay, through DB board. Okay. So by using the sensor, so the controller is trying to control the surplus energy or to prevent this surplus energy go to the grid. So the excess power will go to the dummy load. So different with this one, you have bidirectional arrow here, which is the energy for NEM. The energy can come from the grid, and the customer or the installer can feed the energy to the grid. But this one arrow only, which is the surplus power from this system are not allowed to be fed to the utility. Next one is large scale solar LSS farm, begin in year 2016 until now, regulated and managed by Suruhanjaya Tenaga or Energy Commission Malaysia. Minimum size of 1 megawatt AC and maximum 50 megawatt AC connected to either the transmission network or distribution network in Peninsular Malaysia, Sabah or Labuan. It is selected through open bidding process. So it is estimated to achieve total capacity of 1000 megawatt peak by 2020 with 250 megawatt per year starting from 2017. Large-scale solar is managed by Suruhanjaya Tenaga. So, table 2, annual capacity, allocation, category and maximum quota in Peninsula. So, this is LS bidding cycle from 2017 to 2018. So, we divided into 3 categories, 1 to 5 megawatt, 6 to 29 megawatt and 30 megawatt to 50 megawatt. Okay. In year 2018, 45% come from this category, 50% from this category, and 5% from this category. Another bidding cycle start 2019 to 2020. We can see the improvement here for this category. For 10 megawatt until 30 megawatt, about 50%. 6 megawatt to 9.9 megawatt, 40%. And 1 megawatt to 599 megawatt, about 10%. But please remember, so for this year it's allowed until 50 megawatt, but in this cycle, this LS bidding is only until 30 megawatt AC. So all the detailed information regarding the latest development of renewable energy managed by SEDA is available through this website. Okay. So let's go to the SEDA website. So in this website, you can explore the PV monitoring system. Example here. So in this screen, you can see the Malaysia leading PV monitoring and performance database. So PV nationwide. Okay. So this is in Malaysia. So this is the capacity, 16,732.72 kilowatt peak, and this is the array size, 103,574.54 square meter. So this is the today PV summary. For the whole Malaysia, accumulated energy about 10.16 megawatt hour. So avoidance about 9.059 tons. So this month summary, so accumulated energy is about 4,041.85 megawatt hour. Maximum today is 5,733 kilowatt. Okay. So this is, you can see the monthly report and also for today report. But if you want to have this report, a detailed report, you can purchase from this website. So the price is as low as RM2. So let's go back to the notes. So here is a picture of a solar farm in Aikroh, Melaka, which is 8 megawatt peak. So the shape of the PV array is A shape, facing north and facing south. So this is example component that we need to have in the GCPV system. The GCPV system, it consists of the following component: photovoltaic array, string cable, array junction board AJB, DC fuse, array cable, DC SPD. SPD stand for surge protection device, DC breaker, grid inverter, AC SPD, AC breaker, and energy export meter. So this is the circuit diagram with a single MPPT inverter. Single MPPT means single maximum power point tracker. Okay. So for single maximum power point tracker, in the circuit diagram, it represents by one input terminal only, which is positive and negative terminal. Okay. So this is inverter with single MPPT. So this inverter is protected by this DC SPD on the DC side and AC SPD for the AC side. Also, it have a PV-DC main switch, PV-AC main switch, and PV-AC switch. Okay. Sometimes they include RCD. So from here we can see the PV array configuration. So every string, it will have a string fuse with breaker or overcurrent protection device. So this side we call PV system DC side, and this side is a PV AC side. So the size of the cable, you need to calculate a thing if required. So minimum 10 millimeter square millimeter, single core copper for frame PV module and metal casing. So required if the distance between inverter and the AJB is more than 10 meters. So it required a DC SPD. So the DC combiner, you need to use the IP65. If this DC combiner is installed outdoor, grounding system, you need to refer to IEC standard 62305. Okay. So this is schematic diagram of single phase grid connected with a single MPPT inverter. So this plot diagram, you can get it from the Malaysia standard 1837 version 2018. So this is the latest one. Okay, next one. Okay, this configuration still single phase, but the type of inverter is a multiple MPPT. Multiple MPPT type, which is more than one MPPT. So in the circuit, it will represent by example here 2 MPPT. So if you compare this circuit diagram with this circuit diagram, so the difference is in this part. This one single and this one is multiple. Other than that, still the same. You have DC switch, DC SPD, AC SPD, AC switch, AC main switch. Everything all the same except the connection for the inverter is multiple MPPT connection. Okay, we go to 3-phase. Okay, for this 3-phase system, single MPPT inverter, So this part is similar to single phase single MPPT system, but the difference is this type of inverter is three phase single MPPT inverter. And this connection is different from the single phase single MPPT inverter. If you refer here for single MPPT, single phase, so you only have a live and neutral. Okay, this is single phase. But for three phase, you have three, live 1, 2, 3, and then neutral. Okay, so the difference is on this side. On DTC side, all the same. But for this one, you have a PV AC switch for three phase, AC SPD for three phase, AC main switch for three phase. Okay, and PV meter for three phase. Go to the next schematic diagram or circuit diagram. Three phase multiple MPPT. So on the DC side, same circuit diagram, but the difference here is a three phase multiple MPPT inverter. So on the AC side, you need to draw the three phase system. So multiple MPPT, again, you have more than one terminal because of the multiple MPPT. Another type of GCPV system by using microinverter. So microinverter means a small size of the inverter. Okay, a few watt. Okay. So this microinverter usually connected to one PV module, two or three PV module. Okay. So in this example, one microinverter, one PV module. Okay. So this microinverter usually attached below the PV modules or near the PV modules. Okay. So we have monitoring unit and the breaker MCB. Okay, protection for the inverter. So the earthing, if required, minimum same thing, 10 square millimeter for single core copper. That one for frame, PV module and metal casing. So here we have AC SPD. Because this inverter is already convert from DC to AC, that's why we don't have this DC SPD. So we replace the protection with the MCB. Okay, and then AC SPD, and here the PV AC main switch, and again the RCD, residual current device, and the PV meter. Inverter is quite expensive compared to the single phase single MPPT system. Okay, another one we call this DC atomizer system. Okay, so this DC atomizer actually a DC to DC converter, which is it works as a maximum power point tracker. Example here, one PP module, one DC atomizer. Okay, so it convert DC to DC. So we need a string fuse with breaker or overcurrent protection device. And then PV DC switch. Here protection for the inverter, we have DC SPD, AC SPD. But this inverter is a conventional inverter, not a MPPT inverter. Because we already optimized here. So this inverter is a regular or conventional inverter, convert DC to AC. Then PV AC switch, AC SPD, PV AC main switch, RCD if required, and the PV meter. So we have 6 type of GCPV system. Okay. All the information and the guideline you can refer to Malaysia Standard 1837 version 2018. Okay, grid-connected inverter. So the grid-connected inverter is a special type of inverter. It only works with the presence of the grid supply and cannot directly connected to the load without grid line. So the grid inverter turns on if input DC voltage is within the inverter window voltage. So AC voltage present and its value is within the operating range of the inverter. Frequency of the grid is within the operating limit. The inverter temperature is within the operating limit. So how to know this? You need to refer to the datasheet of the inverter. So let's check this inverter window voltage. Okay, we refer to this smart string inverter by Huawei, model SUN 2000 65 KTL-M0. So the maximum input voltage is 1100 volt. Mean when you make a series connection of your PV module, make sure it's not over than 1100 volt. And this is the maximum current of the inverter per MPPT for each MPPT. So how many MPPT that this inverter have, which is 6 MPPT. So the start voltage is 200 volt. Okay. So the inverter will start to operate starting 200 volt. And then what is the maximum input? 1100 volt. Okay. But the inverter will detect this maximum power point from the PV module within voltage 200 volt until 1000 volt. So rated input voltage is 720 volt. Okay. Number of input is 12. So you have 6 MPPT because the number of input is 12. So you have positive and negative terminals. So this positive and negative terminal, you have 6 unit, okay, because of 6 MPPT. So your maximum input voltage is 1100 volt. So within the limit of the inverter means starting from 200 volt until 1100 volt. So I repeat again, the inverter capable to detect this maximum power point, which is the system can be optimized if the voltage is within 200 until 1000 volt. If less than that or more than 1000, so the MPPT will lose the tracking. But the inverter is still on, but the maximum is 1100 volt. So this is the output. So the active power output with a different temperature. So when you design, make sure you design based on climate. Okay, at 40 degrees Celsius, 45 degrees Celsius, or 50 degrees Celsius. This one depends on the design. Okay. Maximum AC apparent power is about 72,000 VA. And the active power is about 72 watt. This is at the power factor cos theta 1. So the inverter will turn on is if the grid is within the grid frequency. So for this inverter, we have 50 Hz and also 60 Hz. And the maximum output current is 86.7 ampere, but the rated output current is 78.2. So usually in the design, we use this maximum efficiency, 98.9%. So the inverter temperature is within the operating limit. Again, operating temperature range is about minus 25 degrees Celsius until maximum 16 degree Celsius. So make sure your inverter is located in the area that have a very good ventilation. The inverter might damage if the input voltage is higher than maximum input voltage of the inverter. So I said before, for the Huawei smart inverter, the maximum input voltage is 1100 volt. Okay. So if you connect the system, you design the system which is more than 1100, so the inverter can be permanently damaged. Voltage surge from DC side or AC side is example due to lightning. Okay. The grid inverter might turn off during daytime, okay, because of raining or very bad weather. So the input voltage is less than minimum input voltage. The grid voltage is not present or outside the operating range. The frequency of the grid is not stable or outside the operating range. So for the Huawei, the input voltage, the minimum input voltage is 200 volt. Okay, we refer back. What is the minimum voltage? Okay, so the start voltage or the minimum voltage, okay, is 200 volt. So this value sometimes we call window voltage or sometimes we call MPPT window voltage or MPPT voltage range. The grid inverter are classified based on number of phase on AC side, whether it's a single phase inverter or string inverter, or three-phase inverter or central inverter. Number MPPT unit, single MPPT inverter or multiple MPPT inverter. Galvanic isolation, whether the inverter is transformer based inverter or transformerless inverter. And the size of the inverter, which is microinverter, string inverter and central inverter. So usually for three phase, we're using a central inverter, but for string inverter, it's only for single phase. String inverter is a single phase GCPV inverter, usually less than 10 kilowatt. However, central inverter is a three-phase GCPV inverter and its power is more than 10 kilowatt. Single MPPT inverter is an inverter which only one MPPT and it is used with PV module that facing one direction. However, for multiple MPPT inverter, is an inverter with more than one MPPT and it is used with PV module facing two directions. Microinverter is an inverter that caters for one or two PV modules. Sometimes you can go to three. Thus, the roof could be facing more than two directions. DC atomizer is quite similar with microinverter except the voltage output from each unit of DC atomizer is DC and only one non-MPPT inverter is used with multiple DC atomizer. We continue with design procedure. The following steps are used as a guideline to design a complete grid-connected PV power system and sizing process. All the design formulas are based on Malaysia Standard 1837 standard. Step number 1, get clear objective why the customer wants to install GCPV power system at his or her dwelling? Is it for extra income, or simply fill up rooftop, or for business advertisement, or to reduce monthly electricity bill, or as an environmental conscious? Is possible. Ask the owner what type of PV module he or she prefer. So this is a guideline for monocrystalline PV module. So this PV module have highest efficiency, most expensive, and the temperature coefficient is better than polycrystalline module. For polycrystalline PV module, it has lower efficiency than monocrystalline, cheaper than monocrystalline module, temperature coefficient is higher than monocrystalline module. And the thin film module, it has the lowest efficiency, the cheapest, and the lowest temperature coefficient. So this temperature coefficient you already learned in chapter number 3, which is solar photovoltaic. Okay, to check this temperature coefficient, you can refer to the datasheet of the PV module. So which is in the datasheet of the PV module, usually have 3 temperature coefficient, which are temperature coefficient of Pmax minus 0.40% per degree Celsius, means every 1 degree Celsius the power will drop minus 0.4%. For temperature coefficient of VOC, means every 1 degree Celsius increment the voltage will drop minus 0.30% during open circuit, and the temperature coefficient for short circuit current. So the current will increase when the temperature increase. Every 1 degree Celsius, the current will increase 0.06%. Okay, what type of grid inverter he or she prefer? As a guideline, for string inverter, it usually used for single phase AC output. Central inverter, 3-phase AC output. Microinverter, system with multiple orientation. 1 inverter for 1 module. Or 2 or 3 PV module for 1 inverter. And more safety. DC atomizer, system with multiple type of PV module. 1 unit of DC atomizer per PV module. Route for cabling. Location of inverter, breaker and array junction box AJB. Type of mounting, example, is it building integrated or retrofitted? And location to install PV module, in example, which rooftop or which roof side. If required monitoring, then need to install sensor, which is solar irradiance, module temperature and ambient temperature, and then data logger and communication, for example IoT. Type of interconnection, in example direct or indirect connection to the grid. Okay, step number 2, gather detailed information about the site. During first site visit, recall all the following information. Record the roof condition. In some cases, you need to get the approval from the structure engineer. For example, the building is an old building. Logistic, in example, transportation. So is it easy for you to transport or bring the equipment to the location? Safety, surrounding area, workers and component, in example, storage. PV orientation. For Malaysia, looks for roof facing south. Potential shading, use solar pathfinder to analyze shading profile. Tilt angle, look for a smallest tilt angle. So in Malaysia, usually the tilt angle is between 5 to 15 degree. Cable root distance, from inverter to energy meter, from inverter to AJB, and the longest route from PV array terminal to AJB. Okay, step number 3, determine the total number of PV modules. So the following design steps are applicable for string and central inverters only. Based on the input from step 1, you need to determine the total possible number of PV modules to be installed. The possible scenarios are as follows. Scenario number 1, architecture constraint or area constraint. Scenario number 2, budget constraint. And scenario number 3 is energy constraint. Scenario number 1, architecture constraint. So in this case, the roof area is the main constraint. You need to measure the length of the roof and the width of the roof of the PV space area. Assume the gap G between PV module is X meter. For example, in Malaysia, the gap is about 10 to 20 millimeter. The length of the module is Lm and the width of the module is Wm. Consider lengthwise up module. So this lengthwise up is actually we call portrait. Lengthwise up is a portrait orientation. Okay, example here. So this is a rooftop. Sorry, my drawings is not really good. Example here, you want to put a PV module here. This is lengthwise up or portrait orientation. So here is the width of the rooftop, W roof, and here is the length of the rooftop, L roof. So this is the length of the module, and then this is the width of the module. So this is Lm, and this side is the Wm. So to calculate number of module that's suitable for this area, we start with n across up. Across up means across the length of the rooftop, and the orientation is lengthwise up. So you round down. This is the length of the roof. Divide with the width of the module plus x. X is this area. Between these two modules, we have gap here. So this is x. Okay. So then you will get the value for this arrangement. Okay. Okay. Next one is n up. Up means the arrangement of the PV module going up, and another up here is lengthwise up. So you need to round down. Width of the roof divide with the length of the module plus gap. So this is the gap area. So n total up equals to n across up multiply with n up. So n up is this direction. Okay. So why we round down? This is because if we round up, it's already exceed this area. So if we round down, we don't exceed this space. Okay, the number of module is not exceed to this space. Okay, another orientation is consider lengthwise across. Lengthwise across is the landscape orientation. So same concept. So you have a rooftop here. Okay. So this is the landscape orientation or lengthwise across. So this is an across. Okay. Another one is an up across. Okay. So and across. This across represent the lengthwise across, and the arrangement is across the length of the. So this is the length of the rooftop, and this is the length of the module, and this is the width of the module, and here is the width of the rooftop. So and across this direction, round down length of the roof divide with length of the PV module plus gap, okay, x. And up across going up for lengthwise across, so round down the width of the roof divide with the width of the module plus gap. So n total across equals to n across multiply with n up across. So finally, for actual installation, choose the highest value between equation 1 and 2. If both values are similar, then lengthwise across is preferred due to less effect of the accumulative dirt on the PV module.